All right, so in this section, our goal is to be able to find probabilities that involve the sum or difference of independent normal or random variables. Now, as simple as this may sound, there's actually a lot to it, and this section tends to actually be one of the most difficult lessons in probably in my entire AP Stats course. So really take time to go through these problems and to go through the notes slowly and carefully, because at first it's like going to be like a foreign language and you're going to be like, oh, there's no way I can understand this. And it's really because you just haven't really mastered the notation. It's just like trying to write, an English paper, but if you don't know the letters or you don't know how to make words, then of course it's going to seem difficult. But once you know the letters, once you know the words, you realize it's much more possible to do. So I'm going to be always emphasizing that as we go through this unit, because notation is a big deal. All right, so let's look at this first problem. So here we have that at El Dorado Community College, they consider a student to be full-time if he or she is taking 12 to 18 units, and the number of units X that a randomly selected El Dorado Community College student is taking in the fall semester has this distribution. So the units are 12, 13, 14, 15, 16, 17, 18. Probabilities are 0.25, 0.1, 0.05, and so forth. So it's saying that 25% of the students are taking 12 units, 10% are taking 13 units, 5% are taking 14 units, and so forth. So we're going to calculate the mean and standard deviation of X, and then we're going to make a histogram of this distribution. So you're going to basically apply the formula in this problem, and it's again just using notations properly. So in your formula packet, you may see something like this: the expected value of X, or you may see like mu sub X. And again, that just stands for the mean of the random variable X. So let me actually pop out my formula sheet to show you what it looks like on mine. So here we have this, that's the mean of a random variable. And it shows that it's a sum of X sub I times the corresponding probabilities of X sub I. So we have sigma of X sub I times P of, actually I don't like writing it like that. I like writing X sub I times P sub I and summed up. We did an example in the previous lesson, so I'm not going to spend too much time on this, just a quick review. So all you're essentially doing is multiplying the corresponding X values by their associated probabilities and then adding them all up. So this is going to be 12 times 0.25, because this is X1, this is X2, that's X3, that's X4, that's X5, that's X6, X7. And this will be P1, P2, P3, P4, P5, P6, and P7. So I'm going to do X1 times P1, which is there, plus X2 times P2, which is that, plus X3 times P3, and so forth. I'm going to keep on doing that until I get to X7 times P7. So this will be plus 18 times 0.15. When I do that and simplify, I'm going to get 14.65. Now the standard deviation of a random variable X, in this case, we have the standard deviation of the number of units. You'll be given this formula, or some form of this. And again, it's just knowing the notation. Other than that, it's just like an algebra calculation, which can be tedious, at first, but usually when you get further and further in this course, they'll give you these values. But first, it's important that you practice the notation. So, and again, I won't go slow through this. I'm going to go a little faster than I would the first time I teach this, because I covered this in the first lesson. So standard deviation of X. Remember, we want to find the variance of X and then take the square root. And what you do is you sum up all these, and you go x1 minus the mean. So you do 12 minus the mean, which is 14.65. Square that, so x1 minus the mean of x, times its corresponding probability. So times 0.25. I'm going to add that to, and I'm going to jump to the next line. I wish I didn't write so big. Add that to x2, which is 13, minus the mean, 14.65, squared times p2, which is 0.1, plus all the way until I get to x7, which is 18, minus the mean, 14.65 squared times p7, which is 0.15. So what you're going to get is that this will be add up to about 4.2275. And then this is a variance, and so the standard deviation will be the square root of this. Square root of 4.2275. It'll be about 0.2056. Yeah, 0.2056. Or 2.056. I don't know what I'm saying. So there's your standard deviation. All right, now if we want to make a histogram, we're going to have our random variable values on the horizontal axis and the corresponding probabilities on the vertical. So we're going to have 12, 13, 14, 15, 16, 17, 18. They're going to be number of units. So units x. And the corresponding probabilities will go by 0.05, 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. Let's make sure we label it. Probability. And shade them correspondingly. 0.25 for 12 units, 0.1 for the second, 0.05 for the third, 0.3 for the fourth, 0.3 for 15, 0.1 for 16 units, 0.05 for 17, and 0.15 for 18. Not my best sketch, but you get the idea. All right, now let's look at the next problem here. All right, so still dealing with the same, scenario sort of. At the El Dorado Community College, we have that tuition for full-time students is $50 per unit. So we're going to make T be tuition. So T is going to be the tuition of a randomly select full-time student. So then T is going to be 50 times X. And here's the probability distribution. 600.25, 650.1, $700 at 5%, and so forth. We're going to now calculate the mean and standard deviation for this distribution and make a histogram as well. Now, I'm not gonna go through this step by step because it's gonna just be kind of the same idea as before. So I want you guys to just think about this and practice on your own, because the goal with these first few problems is to catch on to the concept between these variables. In this case, T is equal to 50x. And again, we'll have the expected value of T will be, we can write it as the mean of T. Maybe the sum of, T sub I plus P sub I. So sum of T1 is 600 times P1 times 0.25 plus T2, 650 times 0.1, and so forth all the way to T7 times P7, so plus 900 times 0.15. What you're going to end up getting is $732.50. Now, standard deviation, again, use a notation where you use sigma sub t. That's going to be the square root of the variance of t. So the square root of standard deviation squared. And again, same formula, just we just have, you know, different values of our variable, 600, 650, 700. So using the same formula, and let me bust it out again. But remember, you're allowed to have this on your exam, on your AP exam, so you don't have to worry about memorizing them. Make sure you just know how to interpret them. So then this is going to look like the sum of, you're going to have T1, 600 minus the mean, 732.5 times P1, which would be 0.25, plus all the way to T7 minus the mean, so 900 minus the mean, or this is squared, whoops, make sure I put that squared there, square that first, minus 732.5 times 0.15, and square that, of course. And after you do that, you're going to get that the variance will be about $10,568.75. And so the standard deviation will be the square root of this. The standard deviation of t will be the square root of $10,568.75, and that'll be about $102.8. And again, I'm not showing every single step because that's not important right now, but feel free to practice on your own and check your answers with mine. Now, the histogram, same sort of deal. We're gonna have the random variable values on the x-axis or the horizontal axis, the associated probabilities on the y-axis, and then we're gonna graph it like this, same sort of way. And again, feel free to try it on your own, but I don't want to waste, you know, time because it's just the tedious part. But here's what it's going to look like. You'll get that your distribution for tuition will be like this. Now, what's the point? What are you trying to get out of this? Like, why am I, why are you even doing these problems other than for the fun of it? Well, yeah, let me fix that. It's ugly too. Anyways, you want to recognize the connection between X and T in terms of math. So, just like in real life, if you were to go to college, you're gonna have some units and you're gonna pay $50 per unit. You just take how many units you have and multiply by 50, and that's gonna be how much you're gonna pay for your tuition. Now, that's how you get these values. So 12 times 600, or sorry, 12 times 50, give you 600. 13 times 50 will give you 600. 14 times 50 will give you 700, and so forth. So you're just multiplying these X values by 50, and you're gonna get these T values. That's our formula. Now, what it doesn't explicitly say is that you can also apply that for the mean. The mean of X is 14.65, and if you were to do 14.65 times 50, you're gonna get 732.5. Wow. But the point is you want to see, like, that's just a linear transformation. You're just multiplying by a scalar or you by a number. 14.65 times 50, that gives you that value. And you can even apply this to the standard deviation. You take the standard deviation of x, 2.056, and multiply that by 50, you're going to get the standard deviation of t, so 102.8. So you can use this as a shortcut per se, but make sure you understand the concept. So let's go to the next page and let's write these notes formally. So what this essentially is getting at is that when you have a random variable and you're multiplying or dividing by some constant value, you can multiply or divide the measures of center by the same constant value. In that previous problem, it was by 50. So we could find the mean by multiplying the mean of x by 50, get the mean of t. You can also do that to get the quartiles of t, the percentiles of t, and so forth. You can also apply that, as we saw, to the standard deviation. So measures of spread, the standard deviation, also the range. You can multiply the range of x by 50 and get the range of t. So recognize that, because these are going to be very useful in saving you time, but also when you're working through more complex problems, you're going to need to recognize this.